Welcome, everybody. Good morning, good afternoon, good evening, wherever you're at time zone. I'm Jim Loria of Maisie Injector Company, and I'm the moderator for this webinar, Ozone Use in Winemaking. The webinar is hosted by the International Ozone Association, the Pan American Group. The organization is a non-profit organization to promote the safe and effective use of ozone throughout the world. A little bit of housekeeping. If you're having audio problems, you can select your audio device in the panel. And for questions, you can place your questions in the question box. We'll monitor those throughout the presentations. We'll ask them at the end of the presentation of each person, or we can have them at the end of the complete program. Our primary sponsor today is Tersano. They're a manufacturer of devices that produce stabilized aqueous ozone for cleaning. And as for all our webinar series, the IOA webinar series, we'd like to thank our annual sponsors who promote these webinars for us throughout the year. A little bit of discussion about ozone formation. Ozone is 3 oxygen atoms linked together. Oxygen in its natural form is 2 oxygen atoms, the oxygen molecule in nature. And the way ozone is formed is breaking apart that molecule, the oxygen molecule, and recombining it for 3 oxygen atoms. Ozone was first discovered in 1839 by Christian Friedrich Schönbein. He was playing around in the lab, and the oxygen collected at the positive platinum probe gave off a smell, so he called it ozone after the Greek word ozine, to smell. And if you've ever been around a lightning strike or an electric motor that's arcing, you'll smell that pungent smell, and that's ozone being formed. And in order to form it for its useful purposes, it's created through an ozone generator that does exactly that. It uses an electrical charge to break apart the oxygen molecule to form the ozone, the O3 molecule that we'll be discussing through this presentation. And basically, we're going to be talking about how ozone can be used effectively in a number of different applications in the winemaking process. And our presenters will be Christian de Blasio of Pure Fresh Wine. He's going to be talking about the gaseous use of ozone on harvested grapes. And then Alex Bettinardi of Denora will speak about ozone as a winery wastewater treatment solution, treating the effluent coming from the winemaking applications. And with that, I'll turn it over. If Christian's available, I'll turn it over to Christian. If not,
okay. Good morning, everyone. I'm Christian de Blasio. I'm the CEO of Pure Fresh Wine. As Jim mentioned, I'm going to be speaking this morning about applications of ozone on harvested wine grapes pre-crush. A lot of the data that I'm presenting today is done in partnership with a few groups. Number one of the world's leading experts on ozone applications for wine and wine grapes is Dr. Margherita Modesti from the University of Tuscia in Italy. She's done a lot of work going back as far as, I believe, 2012. In collaboration with viticulture departments and universities in Italy and in Australia. Some of the data I'm presenting today also, a lot of credit of it goes to Dr. Kerry Wilkinson from the University of Adelaide in Australia. The people at Tastery, which is a wine analysis lab in San Luis Obispo, have also added quite a bit to the research and what we've done over the last 3 years, and several wineries that you'll see that we've worked with over the years. One winemaker in particular, Ken Bernards from Ancient Wines in Napa, has also one of the earlier adapters and more experienced winemakers using ozone on wine grapes from Napa, California, and he's participated and added a lot to the data we have to show you today. Three of the key items we'll talk about, I'll talk about this morning, are the effects of using gaseous ozone and applying that to harvested whole grape berries. Basically all these applications are immediately upon harvest, right before you go to crushing and ferment. So I'll show you some slides in a moment, but the basic premise is you harvest wine grapes. They're put into harvest bins that have some ventilation in them. They go into a chamber for ozonation for 12 to 36 hours, depending on the application. And then those are temperature controlled chambers, and then immediately afterwards they go into crush. So you're basically adding a day to your winemaking harvest process from field into fermentation tanks. The three results that we have some details and science to talk to you about today are, number one, increasing the bioactive compounds of the grapes and the after effects of that into the wine and through into your fermentation. Ways ozone helps to reduce additives to wine, or the need for chemical additives such as sulfur dioxide down the line in the winemaking process. And the third and final issue that is usually a pretty hot topic, no pun intended, that people like to understand the research behind, is how ozone is used on the wine grapes to mitigate smoke taint from wildfires when it gets in the vineyards. As I mentioned, this is just a quick picture kind of diagram to show you what some of the modern chambers look like that wineries are using to treat wine grapes with ozone in. Most of the wineries around the world that have actually used these at a commercial level are primarily in California and secondarily in Oregon, Washington, and British Columbia. That's where the main wineries are that have been using these systems. There's been more research and testing done in Italy and Australia, more so than in the United States. But commercially, most of the work that's taken off with the use of ozone for wine grapes has been in the United States. Just a couple quick photos here to give you kind of an impression of what it looks like and how it's done. So you can see on the top left, you can see a mobile container. So these are mobile powered temperature control containers. They come in 20 and 40 foot sizes. They can hold between 5 to 25 tons, between 10 to 50 of the half-ton harvest bins. When you use ozone on harvested wine grapes, you do have to replace solid side wine bins with ones that have aeration in them. So you'll see kind of on the left above the Pure Fresh container, those are standard half-ton solid side wine bins. On the right, you'll see wine bins that are have ventilation in them on the sides and on the bottom. These are readily available pretty much everywhere in the world because they're the same types of bins, same manufacturers, but instead of wine grapes, they're mainly used for oranges, apples, garlic, and onions. So they're available everywhere, and most of the wineries rent these bins just as easily as you would the solid side bins. But you need the ventilation to get the airflow and the ozone within the airflow to penetrate and to contact the grape skins. Down below is just a kind of end look of connecting ozone systems with sensor, remote control, and level control. The key thing, and I'm sure my colleagues talking after me would reiterate this, it's one thing to be able to generate ozone, it's another thing to be able to measure the amount that you're using and how you're applying that amount. And that's the key behind ozone, is not using equipment that has on-off switches, but using professional technical ozone equipment that gives you level control. A little bit on the science of what's happening. So again, if we take a step back from the process and just look at the science, this is a lot of the work done in Italy over several years, mainly led by Dr. Margarito Modesti. And this has been repeated. I'll show you in the next slide how they've repeated this process, but the ROS, the oxygen species that we're talking about here in this case is ozone, and what it does to the grapes. So this is all a skin interaction for the most part. There's a sub-reaction with the seed, but it's mainly a skin reaction. And it's a defense mechanism that kicks off. So you basically look at what the grape does and how it reacts to the ozone, and it's a very symbiotic relationship. And the ozone across the surface of the skin forces an oxidative burst in antioxidant component production. And if you follow that down and look at all the pathways of what happens to the grape skin and what it produces, these are all going to be at the bottom here, the C6 volatiles, the polyphenols, the terpenoids. These are all esters, so smell and flavor esters. That's what's happening. So as a natural defense mechanism to the grape being introduced to ozone as a stressor, it's going to produce, in all cases, these C6 volatiles, polyphenols, and terpenoids. All of these, in which we'll show you in a later slide, result in, generally speaking, very positive notes to wine. Dr. Modesti repeated this same process and results for 3 years in a row, 2017, 18, and 19. And every year she was basically measuring the total polyphenol content of the wines with the control versus the ozone treated wines in a very stable research approved environment in Italy and in Australia. Actually, she did this, part of this was done in Australia to validate that this is happening consistently, and it's scientifically proven to be correct that these polyphenol contents are increasing in the wines when you use ozone. So the next slide, obviously people want to know about, you know, what does that, so there's the science behind it. What are we producing? The C6 volatiles, the polyphenols, and in general, okay, so maybe that is good for the wine, but the questions people have is what is it doing to the wine? This is a typical example, and it's going to be different for the different varietals, but there's a lot of similarities in what you'll see. So through the analysis with Tastery, we were able to actually really hone in on what's happening to the wine that's treated with ozone grapes. You can imagine, and I'm sure if there's any winemakers in the call here, you realize that there's thousands of components in the wine that make the flavor, the smells and the flavors and the esters of the wine, both in the sensory notes of the smell and the sensory notes of the palate, thousands and thousands. So what you look at is you look at the ones that percentage-wise are increasing the most. And to a measurable extent, we can look at, and this is for Napa Cabernet Sauvignon grapes. If you look at the bottom two gray boxes, you'll see there's significant increases in 3 compounds in the wine: ethyl isobutyrate, 2-ethyl acetate, and isobutyl alcohol. All of these notes can laboratory be put into categories of what types of flavors these would be categorized as, which are generally ethereal, fusel, rummy alcohol, sweet, fruit, big fruit, red fruit notes. On the notable decrease sides, to phenyl alcohol, ethanol, and ethyl butyrate, you'll see decreases, and this is more of a floral sharp notes to the wine have been decreased. This is typically what you'll see in the Cabernet Sauvignon. There are, you know, very close similarities to these and other grapes. We just haven't analyzed the specific component increases and decreases yet to the other varietals, such as the Xander or Syrah. Moving on to the reduce of sulfites in wine, the premise is that down the road, the idea is that whether you're fermenting wine or you're aging wine, during that process, as most people close to the wine industry know, from whether you're in the fermentation process or whether you're 2 years in a barrel and you're analyzing the wine, generally winemakers always look for the total free sulfur content of the wine. If the free sulfur content of the wine is the same as it was 2 months ago, that means that the sulfur that you've added is stable, it's doing its job, there's not a lot of bacteria or Brett in the wine, it's not degrading the wine, and you don't need to add any more sulfur. If they measure the free sulfur in the ferment of the wine and the free sulfur amount is low, that means that it's being used to combat bacterias and Brett and things that you don't want in the wine that will degrade the wine and not good for the long-term stability of the wine. So that's the whole idea, is that that's what's fighting a lot of the things you don't want in wine. In the ozone world, this is kind of combining gas and water. Most of the work, again, done by Margarita Modesti, was to look at both washing the grapes with ozone water and the equipment with ozonated water, all the winemaking equipment, and doing a 24-hour gaseous ozone treatment at 50 degrees Fahrenheit, and processing the wine into barrels, into storage, and then into bottles. And doing this to see, does the wine hold up? This was done with wines again in 2017, 18, and 19 with no sulfur added. And as of December 1st, which was the last report I got from Italy, from Margarita Modesti, as of December 1st, 2022, all of these wines that they made had not destabilized. They were all very stable, very positive, and taste very good. Meaning this is a possibility for the future, that if you're managing ozone correctly in your winemaking process with application in gas and cleaning primarily the equipment with the ozone water systems that are in the world today, you can put yourself in a position where you can add little to no sulfur down the winemaking process, which I think is most people would agree could be a good benefit for wines. This is a lot of the results that were done, particularly in looking at preventing Brett development in wines and the positive ozone attributes to that, gaseous ozone, and how it works. Brett is tough to control in some wineries, and it's also able to tolerate sulfur dioxide. So even if you're using sulfur dioxide, SO2, most Brett can handle being around SO2 and not go away. So it's a tough, Brett's a tough issue to get rid of. Ozone's a bit stronger than at the right levels than SO2 is, and it can attack the cellular constituents of Brett and break it down, which is why it's a good solution, particularly for wineries that have battled over the years with either Brett in the field or Brett in their winery. It's a great solution, both on the grapes gaseously and as my colleagues will talk about, using water washing in your wineries down the chain. Just more data and the analysis that they've done to look at the science and the facts and the analysis behind inoculating grapes with Brett and using ozone treatments to them, and measuring how ozone can control and knock down the Brett that's in the wine and in the grapes. Final topic is talking about reducing smoke taint in grapes. And most people, you know, it's good that we talked about the two prior uses prior to this, meaning the use of increasing polyphenols in flavor, fruit, esters of wine, and about the breakdown and chemical analysis of using ozone to get rid of bacteria in Brett, and the molecular structures that we showed on the prior page that ozone can interact with and break down. Because the reality of using ozone to mitigate smoke taint actually incorporates both of those techniques. So it's when you look at, I'll show you a page here in a moment or two, when you've done this successfully to mitigate their smoke taint issues, primarily commercially in California, Oregon, and British Columbia in 2020 during the heavy smoke impact year of 2020. Every single winery that used and winemaker that used ozone systems on a commercial basis will tell you that it did mitigate their smoke problems and put them in a position where they did not have to throw away their wine, and they were happy with the quality of it to sell it at high-end levels. We're talking, you know, Quintessa wine at $300 a bottle, and Rumbauer wine at $100 a bottle, and things like that. So it's definitely feasible, but it's not a one-piece solution. It's really a complement of the knocking down of some of the volatile phenols by ozone grabbing what it can on the surface and on the outer layers of the skin, and the polyphenols and the cover that you get from the natural excessive extraction of polyphenols that ozone causes in the grapes. So it's really a dual mechanism. These are some results that were done in Australia. So on the top left, the graph there, what you'll see, the most important lines there are the black is the control. So when 50 wine experts tasted wine, this is the result of 50 wine tastings from 50 wine experts from 5 countries of these wines that were controlled and smoked, treated with and without ozone. The black is the control. So when you look at fruit notes and smoky notes or ashy notes or medicinal notes, the control, meaning no smoke impact of this, I believe, Syrah, was the black line. What you'll see is that a particular application of ozone, which is the, I believe it's the dark red line, which is smoked grapes and then a treatment of 24 hours of 1 part per million ozone, is the one that got the grapes that were smoked closest to their original profile. And you'll see that other things like not using ozone or using too much ozone actually bring you further away from where you want to be to get back to the natural flavor and sensory notes of wine. Just some notes from the winemaker that's probably done this more than anyone. Ken Bernard's has used ozone consistently in the winemaking process since 2017. What he looked at during, these are just some notes from Ken, is that they've done blind tastings with staff, and they have not been able through any tastings to notice any increase in the smoke over time, meaning after they've treated smoke impacted grapes with ozone, years have gone by with tastings that they've done, and the smoke has not come back, which is a key thing that most winemakers are concerned about with smoke, is something to do to the wine in fermentation or winemaking to cover it, and then 2-3 years down the road in the bottle, does the smoke come back? And Ken has been able to validate with ozone it does not come back. He mentioned that using ozone treated grapes that ultimately allow the wine and the grapes to be used for their intended program, meaning if you have smoke impacted Zin or Syrah or Petit Noir, you can use it for that program without having to sell it for bulk or blend it into a red blend. It can be used for what it was intended for, and not declassify the wines. There's a lot of things to look at for the future and what winemakers are still considering. How do you handle the extraction? There are wineries that have too much extraction as it is, and do they want that? Maybe not. And there are wineries and varietals around the world and regions that have a problem with not enough extraction, where it is a good application. So really looking at the evolution, longevity, stability of the wines, how does ozone fit the stylistic goals of individual wines and winemakers? That's going to take a lot of work. These are just some of the wineries, just to give you some examples that are actively using ozone for different programs, mainly across the U.S. West Coast, from Washington, Oregon, down and mostly in California. And some things to, again, summarize what we talk about, why you'd want to use ozone for your harvested grapes to decrease SO2 use, deal with microbial competition, getting rid of bad microbials that you don't want in your wine, dealing with compromised fruit, bird damage, mold, etc., making wines more approachable. This is the polyphenol impact. People are really now looking at the studies of how do consumers react, and it is positive data that's coming out on wines that are treated with ozone, mainly being classified as more approachable by the consumer. And there's also some good applications for underripe fruit and why you want to use ozone on those applications. So again, my name is Christian, and I just want to thank Jim and the International Ozone Association for the opportunity. And Jim, do you want me to do questions now or wait to the end?
Yeah, I've got a couple of questions, Christian. Yeah, let's do some quick questions. If we have some other ones, we can answer them at the end. But I think there's one really important one, and thanks for the very interesting presentation. There's one that recognizes that ozone is a very strong oxidant, and they were wondering if this does not destroy the desired antioxidants like resveratrol and the other antioxidants that make wine its special drink. So can you address that?
Yes, so I did talk that obviously this data will be released to everyone on the call, and the answer is it actually increases antioxidants. We actually presented that on the third or fourth slide today. So as part of the stress reaction of the grape and the grape skin to the ozone, it produces more antioxidants in order to defend itself. It's a natural reaction for the grape to produce more antioxidants, not less.
All right, great. And then I have a question myself. You know, we first met at the North Coast Wine Show, and we were doing some taste testing, and I was just wondering, based on the blind taste testing from just novices like myself, what kind of results can you tell us you've seen?
So in 75% of the tastings, the blind tastings we've done, and not only has this been, you know, over 50 wineries that have done these types of tastings, but in big groups such as seminars and wine symposiums in Australia, in California, last year at the North Coast Wine Symposium, we've had hundreds of people actually fill out surveys and do these blind tastings. It's about 75% that you'll see of preference towards the side-by-side wines, where 75% of people prefer the wines that we're treating with ozone.
All right, great. Well, thanks, Christian.
So good morning, good afternoon, everybody. My name is Alex Bettinardi. I'm the Global Product Manager for Ozone and Advanced Oxidation Processes at Denora Water Technologies. I'm working with ozone since 2012, I believe, and I'm with Denora since 2015. This is the last session of this webinar. We'll have some time for Q&A after this session as well, so continue to send your question in the chat in the meantime. We're switching a little bit gear here because in this last session we're going to talk about ozone as a possible wastewater treatment solution for the wine industry. The next 25 minutes, we will go through a quick overview of the ozone oxidation chemistry. Then I'll give you an overview about how ozone is applied in general in wastewater treatment processes. And then we will talk about typical challenges of the wine industry when it comes to wastewater management and treatment. And how ozone can represent a solution for some of the water quality challenges that this industry is facing, also through a couple of piloting experience that we have recently conducted here in Italy. So ozone reactions are oxidations. And they can proceed through two different mechanisms, the direct or the indirect. The direct reaction happens when the ozone molecule basically uses the third unstable atom of oxygen to target and oxidize organics molecule, targeting specifically unsaturated bond. And because of that, it's a pretty selective reaction. People used to say, oh, ozone is going to oxidize everything, it's not selective. That's not really true. The direct reaction is specifically targeting unsaturated bond. Vice versa, there is another reaction that can be leveraged that is called indirect reaction. The indirect reaction of ozone oxidation is carried by hydroxy radicals. And these hydroxy radicals can be generated in the water by injecting hydrogen peroxide, basically. Hydroxy radicals are stronger than ozone, are faster than ozone, and are less selective. So in some situations, especially when it comes to wastewater with very complex metrics, very complex organics, sometimes ozone cannot do much. And so we need to leverage a different mechanism, and that's when we go AOP, we go advanced oxidation process by injecting peroxide and producing hydroxy radicals that are less selective. I wanted to give an overview, but actually today we will see that the direct reaction when it comes to a winery wastewater and targeting specific parameters, the direct reaction is effective enough and enough to reach some treatment targets. In wastewater treatment, generally speaking, ozone is mainly applied as a tertiary polishing treatment. So here in the picture, you see a very, very general standard schematic of a wastewater treatment system and wastewater treatment scan. So there is a pre-screening to remove big solids. There is a primary normally chemical, physical treatment with sedimentation, and then there is that is followed by a biological treatment. Ozone is normally applied downstream, so after all these pre-treatments, and generally speaking, can be used to target, for example, recalcitrant organics, recalcitrant COD or TOC, depending on the region where you are. You might look at that as only COD or as total organic carbon. You can target BOD. You can use ozone to remove color and odor. You can reduce toxicity if you are discharging your effluent, your wastewater in a surface water stream, a river, a lake. You have to comply with some toxicity requirement. You can use ozone to oxidize a specific molecule, surfactants, phenols. You can use it to oxidize micropollutants or more in general contaminants of emerging concern. And it's also applied for water reuse application, direct indirect potable reuse, or agriculture. Water reuse, and for some very specific application can be used also to reduce some ammonia, and we will see that we have experienced that as well with a couple of the case history we will show today. And of course, it's a disinfectant. It's not the main purpose. You want to apply ozone for wastewater treatment, but it's a disinfectant as well. We will also see that ozone, yes, it's normally applied as a tertiary treatment, but it can also be used as a polishing technology after different type of treatment trains. For example, treatment systems that are not using any type of biological process, for example. This is a very general process schematic showing how ozone is applied for water treatment, not just wastewater, water treatment in general. But it's pretty consistent through all the ozone for water treatment applications that we mentioned just in the previous slide. So every ozone system is equipped with a feed gas preparation system. Here you can see an oxygen tank, but Brian was talking about oxygen, on-site oxygen producer, concentrator, PSA as an alternative option, for example. Of course, you need to have at least one ozone generator to produce your ozone. When it comes to generator, normal drinking water, chiller, but you might have a plated exchanger as well. And then you need to inject that ozone into your water. So you're going to need some type of injection systems, porous diffusers or side stream injection system leveraging a Venturi ejector like the Mazy system, for example, or static mixer or other type of mixing system. And then you have an ozone reaction chamber. Normally, when it comes to wastewater treatment or water treatment in general, you need a certain contact time to allow ozone to do its job, basically, and to allow the chemistry, the kinetic to happen. So you need an ozone reaction chamber to ensure the proper contact time. You will also have an ozone destruct unit when it comes to these mid-size, large-size ozone generator. You will never be able to transfer into the water 100% of the ozone that you are producing. So you need to be able to capture that excess of ozone and destroy it and reconvert it back to oxygen. So you're going to have an ozone destruct unit. And of course, the entire system needs instrumentation and safety devices like leak ozone monitor, leak oxygen monitor to operate safely the entire system. When it comes to an ozone peroxide AOP process, you can immediately recognize that basically the overall schematic is the same. Actually, the picture is exactly the same. The big difference here, of course, is represented by the peroxide injection. Peroxide is normally injected immediately before the ozone injection. Normally, there is a static mixer or some type of mixing technology to make sure that peroxide is efficiently mixed with the main water stream. And when peroxide is applied, there is an important parameter that comes into the picture, that is the ozone to peroxide ratio. And that's a parameter that normally is defined during the pilot testing. And in a minute, we will talk about, we'll also talk about piloting and the importance to pilot this technology, especially when we are dealing with wastewater that can, of course, have a completely different metrics between one side and another side, even within the same industry. From a layout or general arrangement perspective, these type of systems normally are delivered as a containerized solution with a separate ozone contact tank. Here is a typical example with a 20-feet container, including all the equipment you can see in the picture here. We have the ozone generator, we have the cooling system, we have the feed gas preparation system here. Also instrumentation, main PLC normally are all included into the container. And then you can see the separate stainless steel vertical tank that is our ozone reaction tank. You can see the container here that there is also a thermal ozone destruct unit to capture the excess of ozone. And the reason the systems are containerized is because normally ozone comes later. No one normally is going to design upfront a wastewater treatment system, especially for a specific industrial application with ozone. They discover that they need ozone after. So the easiest way to deliver this technology and to minimize the installation time and installation cost is to have containerized solution. And if we think about the wine industry, very often customers require this technology mainly and maybe just for a limited amount of time over the year. So it's important to have a mobile and temporary solution that can be installed only when needed, for example. So winery wastewater is typically generated from washing operation during grape harvesting, pressing, fermentation, and as well from the wastewater contains a huge amount of biodegradable organic compound, but also together with concentration of phenolic compound, sugars, organic acids, and nutrients. Here we have listed the major challenges. Oh, sorry, can you still see my screen?
Yeah, we can still see it, Alex.
Yeah, okay. Here we have listed the major challenges that wineries have to face in regards of management of their wastewater. First of all, the water quality varies based on the facility operation, the cleaning procedures, and the chemicals they are using. We know that different part of the world, but even same part of the world, different wineries gonna use completely different chemicals and strategies. The effluent quality and volume vary seasonally. That's probably the most important thing. During grapes harvesting and pressing, of course, you have a much larger volume of wastewater to manage. There is presence of recalcitrant COD. We will see that about 20-25% researchers have proven that 20-25% of that COD is recalcitrant. So traditional biological processes are not really able to treat completely that COD, that part of the organics. BOD and COD have to be reduced as per local regulations, depending on where the winery is discharging the wastewater. There is presence of color, so if a winery is discharging again into a river, for example, needs to make sure that the water, the effluent is completely transparent. Also ammonia, so nutrients as well, ammonia, nitrates, nitrogen in general, in some area needs to be reduced as per local regulations. Here we can see a couple of tables. These are taken from the literature, but actually these are a very good average representation of what winery wastewater characteristics looks like. Organics, as we mentioned, are usually the critical parameters these wineries need to struggle to comply with. And we mentioned that especially in some time of the year, the volume increased dramatically. So the existing treatment might not be enough to treat that volume and that load. Some countries are more focused on the BOD. There are other countries that are looking at TOC in general. Other countries are looking at both BOD and COD. And depending where you are discharging, you might have more pressure on one parameter versus another. And as we mentioned before, 20-25% of that COD can be recalcitrant in some cases. So traditional biological processes might not be enough to deal with that type of organics. Here we have some pilot data from a couple of recent experiences. So the first one, here we are in Northeast Italy. This is the Valpolicella area where Amarone, Ripasso, and these type of wines are produced. So here we have a company that is treating their wastewater without any biological process normally. So they just have a pre-screening to remove most of the solids and some settling, some sedimentation tank, and just an ultrafiltration stage. And they are basically discharging into the municipal wastewater treatment plant that is down the road. Unfortunately, in the last couple of years, the municipality have asked them to reduce their organics load, especially during crush time, so harvesting and that time of the year. So basically, you can see that the ultrafiltration, their ultrafiltration system is already able to cut by 50%, basically both COD and BOD. But then they wanted to evaluate if they needed to, well, they have to upgrade their system because that's their requirement to continue to be able to discharge. They have evaluated other type of membranes, but they've also wanted to evaluate ozone. So went there with a pilot system, and these are the results basically. So we were able to obtain a 40% reduction of the COD after ultrafiltration stage, and also a similar type of reduction with BOD. This is pretty interesting because most of the time you will hear some people that are used to deal with ozone telling you, oh, BOD actually can be increased. And that's true. For some type of water, you reduce COD, but actually you are increasing. So you are reducing the chemical oxygen demand, but you are increasing the availability of biodegradable organics, so biological oxygen demand. Lucky for us and for these industries, ozone is actually a technology that can reduce both COD and BOD. So we didn't experience that effect of COD reduction, but BOD increase. And during this time, we also made some analysis on ammonia, and we also experienced up to a 90% of the ammonia. So just to be honest, ozone is not the go-to technology if you are targeting only ammonia. The ammonia oxidation happens mainly through hydroxy radicals, and it's a very slow reaction. But it's a bonus. Let's say it's a bonus that you get. Some of the ammonia, I'm sure, is being removed just through a stripping effect because of the gas injection, oxygen injection, ozone injection, but a part of it has been also oxidized. This is the second trial that we did recently as well. We are still in the northeast of Italy, but we are in the Prosecco area here. The target here, so this company, it was not basically treating their effluent. They were paying a third-party company to take their water, and they were paying this company to take the water and dispose the water into third-party wastewater treatment systems. They wanted to evaluate, and during crush time, they were spending thousands of dollars per week for that. So they wanted to evaluate if they could have been able to their wastewater to be able to discharge in the sewer into the municipal wastewater treatment plant of the city, basically. The target was to reduce COD below 1,000 ppm. That's the level that was requested to be able to discharge into the municipal wastewater treatment plant. So we went there with a pilot as well, and you can see the ozone to COD ratio is pretty consistent and consistent with the previous one, but I can assure you that it's consistent also with other tests that we have done. So a ratio, an ozone to COD ratio of 3 seems to be pretty consistent when you're dealing with organics in this type of wastewater. And also we also observed a complete decoloration or color removal of the effluent as well. That, as we said before, it might be an important parameters when you are discharging into another wastewater treatment plant, but if you have to discharge into a river, into a lake, that might be an important parameter as well. So I mentioned already a couple of times piloting. The chemistry behind ozone oxidation, especially in wastewater, and behind advanced oxidation processes is often very, very complex. A lot of mechanisms, especially for some unusual organics molecules, are not even fully understood. And that's why when you have to deal with a wastewater, at some point, you're going to need to run some type of pilot test. Of course, the experience, the literature help us to give some initial figures. If we receive a water quality analysis from a customer based on the test we have run and the literature, we can say, yeah, we can hit that target and the ozone system will be this dimension, this cost. That's something that can be done up front. But at some point, some type of pilot will need to be conducted just to confirm the initial design. There are basically two big groups of piloting activities that can be done. There are what are called lab scale, bench scale tests that normally are used for feasibility study. For example, I don't know what's going on, what is going to happen with that water. Take a sample of water, inject some ozone, and make some analysis, and I can tell the customer, oh yes, ozone might be a valuable solution for your water quality issue. But that's not any indication on the actual sizing of the ozone generator. The second step normally is an on-site piloting. We're not talking about long campaigns, especially if you're targeting parameters like organics, like COD, BOD, color. It's something you can prove with a week of testing. So we're not talking about long campaigns of piloting, but these type of pilots will give you the absolute will give you real data and real value about the actual ozone demand that your specific water is looking for to hit that, that target on that specific parameter. And there are different types here. There are pilots combining ozone with peroxide. There are pilots combining ozone with filtration technologies if you need an extra polishing on top of solid, for example, or there are some other pilots that are normally used for batch tests. In conclusion, ozone, we can say that ozone definitely represents an effective solution to solve wineries' wastewater quality issues, especially if these issues are related to organics and the need to reduce those organics. We said COD, TOC, BOD, depending on the different area, depending what we are specifically targeting or asked to comply with. Ozone is a plug-and-play technology. It does not require any acclimation time typical of biological processes, for example. So it's ideal to face a seasonal issue. You can switch it off and turn it on within a few minutes. So really something plug and play and that you can use only when needed. We saw how ozone can definitely be a solution for COD reduction, but we knew that. But for this type of wastewater is also a very reliable solution to reduce specifically BOD as well. As a side effect, ozone, of course, is also going to remove color, remove some of the ammonia and nitrogen compounds that are in the water as well, even if ozone is not the primary technology to do that. But that's a bonus, a side effect that you get together with the disinfection, of course, of that effluent. And of course, we saw how pilot is actually very important because the metrics of these wastewater, even if they come from the same industries, might be very, very different depending on what the specific winery and the specific company is using for their processes.
Thanks, Alex. I really appreciate that. Very interesting presentation. We got a couple of questions, and I'm going to read this one directly because I just want to make sure I got it right. To address toxicity hazard in the open top wastewater treatment pond where ozone is injected, are there any threshold ozone concentration above which an enclosed pond with O3 destructor must be provided per good industry practices? And I think the question they're asking about, safety concerns of any of the ozone being rising up to the top of the tank, and how is that being handled?
Yeah, absolutely. So I believe the number they're looking for is 0.01 ppm. That's normally what we guarantee with our ozone destruct unit. The reality is that even if you have a very, very efficient injection system like the Mazy, for example, side stream injection system, you really reach a high transfer efficiency up to 98%. You always have a certain amount of ozone that is going to be released from the tank. So when it comes to wastewater treatment system, we always recommend to inject that ozone into a closed ozone reaction chamber. Can be a concrete tank, can be a stainless steel, but we always recommend that. An ozone destruct unit will always be there. Because when it comes to wastewater, the concentration of ozone that we use is normally high. It's normally high, and we need to make sure that we capture any traces that can be released by the system.
Okay, great. And I have a question. So Washington State and California out here on the west coast of the U.S., the governmental regulators are putting more burdens on and requirements on the wineries to treat their wastewater effluent. Do you have any pilot units here in the United States, or any wineries that are currently looking at using ozone for this treatment? I know you're doing a lot of work in Italy, but can you address that?
Yeah, so we don't have any active pilot, but for this specific reason and other environmental requirements in the US, actually the 3 pilots that I was showing in my slide, they are all available in the US. And the wine industry is one of the industries that we want to target, because exactly what you were mentioning, California, not only, they are coming out with more and more stringent regulations, especially on BOD and organics level discharge. So yes, we have pilot available in North America.
Okay, great. Okay, great. And then there's one question, and I'll take this one. Question about the application of ozone in irrigation applications. And because it's not typically used in the wine vineyards, because of the fact that you really have to make sure that the air is being clean and dust-free going into the ozone generator. I mean, there are some irrigation applications in open fields where they're using ozone to sanitize, to disinfect, but they're few and far between. Where they are being used quite extensively in irrigation is in vertical farms and in greenhouses, where it's an enclosed environment, and ozone does an excellent job of destroying the biofilm in these systems. And Maisie's got a number of these systems out there in the market for different grow houses, like for cannabis, for tomatoes, for indoor growing of strawberries. So ozone does an excellent job of destroying the biofilm that harbors some of the pathogens that can really hurt the growth of a lot of these indoor crops. So with that, that concludes the webinar. I want to thank the sponsors, especially Tersano, for being the primary sponsor of this webinar, and also for our year-round sponsors for supporting our IOA webinar series. So thanks again, and if you want to have access to this recording, you can go on the IOA website at some point. I'm not sure how long it's going to take for us to upload this, but it should be there pretty shortly. Thank you very much.